Dear students, welcome to the class of business mathematics again. In this video, I am going to discuss about break-even analysis. This is part 2 of this topic, and in this video, I am going to discuss 5 problems. So let me read problem 1 first. A manufacturer of compact disc has a fixed cost of $10,000. So this is the fixed cost. This will be our C in the cost function, because our cost function we know y equal to mx plus c. So this C is the fixed cost, and variable cost per CD is $7. So this is the variable cost per CD, that will be m in the cost function, and selling price per CD is this. This is small p. In the revenue function, we know revenue R equals small px. So this is small p is this selling price per unit. Now find the revenue function, cost function, and profit function. And in B, it says what is the profit if 2800 CDs made and sold. So we need profit function in order to calculate profit of this amount CDs. And what is the profit if 1000 CDs made and sold? At what number of CDs made and sold will manufacturer at break even? So what number of CDs made and sold will the manufacturer at break even? We need to calculate break even quantity. And E, at what sales volume? Sales volume means revenue. Will break even occur? It means what is the revenue at break even? What is the revenue at break even? So let us denote the number of CDs, which is the number of quantity made and sold, by X. Then the first function we want to calculate revenue function. So the revenue, we know selling price per unit times quantity, or simply we can say price times quantity. And here selling price per CD is $12. So the revenue R will be 12x. But since the question tells us function, revenue function, so it's better if you write R as a function of X, because revenue depends on X. But if you write simply R, then it is also okay. This is also no problem. R equal 12x. But it is better to write in this form R as a function of X, which is 12x. This is our revenue function. And the second one is cost function. Cost function, we know y equal to mx plus c, and m equal to 7, c equal 10,000. Therefore, our cost function will be 7x plus 10,000. However, this y also depends on x. So you can write y as a function of x. It is better. But if you write simply y, then it is also okay. And the third function is the profit function. Profit function, we know profit equal revenue minus cost. So revenue function equal 12x minus 7x, 12x minus 7x plus 10,000. So because of this negative sign, it will be 12x minus 7x minus 10,000. You can write it directly, which is 5x minus 10,000. This is our profit function. Px, profit also depends on x. So in functional form, we can write Px equal, P as a function of x is equal 5x minus 10,000. So the answer of A is complete. Now B, what is the profit if 2800 CDs made and sold? So we need to take help from profit function. And for 2800 CDs, it means you need to replace x in the profit function. Replace x by 2800. So profit for 2800 CDs will be equal to 5 into 2800 minus 10,000, that is $4,000. So the profit, if 2800 series made and sold, will be $4,000. And in C, what is the profit if 1000 series made and sold? In that case, the profit will be negative $5,000. And I said in our last class, negative profit indicates a loss. So I should write which indicates a loss of $5,000. So loss, when you will write loss of loss, then you should not use this negative sign again, because this negative sign indicates loss. So when you will write loss, then it will be direct $5,000. You should not use any negative sign here anymore. And D, it says what is the break-even quantity. So we know at break-even point from our last lecture, part 1, we know at break-even point profit equal to 0. So profit function is equal 5x minus 10,000. Now we can replace px by 5x minus 10,000, which gives us x equal 2000 CDs. It means break-even quantity 2000. And finally, the question is, what is the revenue at break-even? At what sales volume will break-even occur? It means what is the revenue at break-even? This is our revenue function, and we know break-even quantity is 2000, so it will be 12 into 2000, which is 24,000. Now let me draw the break-even chart. So it will be, in this case, very simple. You see, this is x-axis, y as well as r-axis, and this is our x-axis. And x indicates number of quantity. This is origin. So our cost function is what? Y equal 7x plus 10,000. Y equal 7x plus 10,000. And revenue function, which is equal 12x, and break-even quantity $2,000. So the break-even point will be 2,000, comma, and when x equal to 2,000, r equal 24,000, or y equal 24,000. You can put 2,000 here, it will be also 24,000. So this is the break-even point. Now it's very simple. Let's say the break-even point is here. This is 2000 is here. This is a rough sketch, and 24 break-even point. Let us consider this point. So if this is 24,000, then y-intercept is 10,000. So 10,000 will be approximate to here. Now the cost line will start from here, from this point, and it will passes through break-even point. This is the cost line. And again, revenue line will start. We know from our previous lesson, break-even point will initiate from the origin and passes through the break-even point. Revenue line will start from the origin and passes through break-even point. So this is the revenue line. Let's say r equal to 12x, and this is the cost line, which is y equals 7x plus 10,000, and this is break-even point, which is the coordinate of this point 2000 and 24,000, and the coordinate of this point is 0, 10,000, because y-intercept is 10,000. You see, this is also fixed cost, and marginal cost is 7, but we don't need marginal cost in this problem. In your question, do not tell you to calculate marginal cost, so it's okay. And this is the loss region, this region is the loss region, and this region is the profit region. And if your question tells you to draw fixed cost line, then you can draw it. This is a line which will initiate from this point, and that line will be parallel to the x-axis. It means any point on this line will indicate fixed cost. So this is fixed cost line. Fixed cost line. And if company produces less than 2000 CDs, then company will be in loss of this amount. If you subtract R, this is R and this is Y. If you subtract R from Y, then this amount will be the loss for 1000 CDs, and we know for 1000 CDs there is a loss of 5000. So this amount will be 5000. And if there is no production, then the fixed cost will be the total loss. And when company produces more than 2000 CDs, for example, let's say 3000 CDs, then there will be a profit of this amount. R minus Y will be the profit. But here Y is greater than R, so this is the loss region, and in this region R is greater than Y, it means revenue is greater than cost, so this region is the profit region. Therefore, this chart is the break-even chart or diagram for this problem. Now let's try to understand the next problem, and this is exactly same problem, but let me discuss quickly. A manufacturer of cassette tapes has fixed cost of this amount. So this is your C in this problem, and variable cost of $6 per cassette produced. This is your M. Selling price is this per cassette, so this is your small p. Find the revenue, cost and profit function. What is the profit is 2500, 25,000 cassettes are made and sold. What is the profit if 18,000 cassettes are made and sold? But what number of cassettes made and sold will the manufacturer at break even? And what is the break even dollar volume of sales? So the problem is exactly same. Therefore, the cost function here will be mx, m is 6, mx plus c, which is 60,000. And the revenue function will be price into quantity, selling price per unit, which is 9, so 9x. Therefore, the profit function will be revenue minus cost, which is 9x minus 6x. So 6x minus 60,000 will be your profit function. So we know revenue function, we have calculated already, and this is the cost function, and profit function will be this 3x minus 60,000. Now you can calculate profit of 25,000 CDs made, cassettes are made and sold, that will be 15,000, and for 18,000 cassettes made and sold, there is a profit of minus $6,000, which indicates a loss of $6,000. And for the break-even quantity or break-even point, we need to put profit equal to 0, and profit Px is equal 3x minus 60,000, which is this, and that gives us x equal to 20,000. So this is our break-even quantity, and at break-even revenue is this. So in this problem, the break-even point will be 20,000 comma 180,000. So this one will be your break-even point. So let me draw the break-even chart quickly. Just a quick draw will be fine, I think, for all of you. Now this is our x-axis, which indicates number of quantity. This is y as well as r, and break-even point 20,000 and 1,80,000. So let's say 20,000 is here and 1,80,000 is this point. This is the break-even point. So the cost line will start from where? It will start from 60,000. So if it is 1,80,000, 60,000 will be near this place, and revenue line we know will initiate from this point. Therefore the cost line will start from this point and passes through the break-even point, and revenue line will start from the origin and passes through break-even point, and break-even point has coordinate 20,000, x coordinate 20,000 and y coordinate 180,000. This is your break-even point. This is your r, this is y, and another line is the fixed cost line, which is this line. Fixed cost line is this line. So this is your fixed cost line, and this is how you can draw your break-even chart. And you know this is the loss region, and this region is the profit region. So now let us think about the next problem. This is also exactly same, but the difference is here your question tells you to use Q for the number of units. In our previous two problems we used X for the number of units, so here you need to use for the number of units and nothing else. Everything is as usual. Here your question tells you construct break-even chart, label the cost revenue lines, fixed cost line and break-even point. So you can do that. From here you will get break-even quantity, and from this one you will get revenue at break-even quantity, and you need profit function for B and C. So let us think about revenue function will be what? Revenue will be 5Q in this case, and you can write R as a function of Q, which is 5Q, and cost line Y, that will be mx. M is this amount and this is C. So 2Q, instead of X we need to use Q, plus 60,000 is the fixed cost. So you know revenue line, you know cost line. Now you can calculate profit function, revenue function, cost function, and profit function will be revenue minus cost. So that will be this one, and you can calculate profit for 2,500 units. That will be $15,000, and profit for 10,000 units will be minus $30,000, which indicates a loss of $30,000. And for the break-even quantity, you must need to equate profit equal to 0, and 3q minus 60,000 is the profit function that gives us q equal to 20,000. So this is your break-even quantity, and break-even quantity, at break-even quantity the revenue will be 100,000. So now by using these informations you can draw your break-even chart, and this is already given here. The cost line will start from this point 60,000, and break-even, the coordinate we should write in this way, 20,000 comma, there should be 1 comma, 100,000, there should be 1 comma between x and y. So I think you all understand break-even chart by this time. So please try to understand this one again. And let us think about problem 4 now. Problem 4. And in this problem, this one is your C, and this is your M, this is your small p. So you can calculate, you need to use Q for the number of units. So you can calculate revenue function, that will be 50Q, and you can calculate Y, that will be MQ. M means 20, MQ plus 120,000. And by using these informations you can calculate profit function, that will be revenue minus cost. So it will be 30Q minus 120,000. So by using profit function you can calculate profit for 10,000 units, and you can calculate profit for 1,000 units. You can calculate break-even quantity by putting profit equal to 0, and you can calculate revenue at break-even. From here you will get break-even quantity. So this is your revenue function. It is already, the solution is here. This is your cost function, and this is your profit function. And profit for 10,000 units is this. Profit for 1,000 units is minus $90,000. It means a loss of $90,000. And for the break-even quantity you must need to put profit equal to 0. That will give you Q equal to 4,000. So this is the break-even quantity, and if you put this result in revenue function you will get break-even y coordinate or r coordinate of break-even point. So break-even point will be 4,000 comma 200,000. So this is your break-even point, and now you can sketch break-even chart. And please try to understand this chart by yourself, because we already discussed this chart in each problem. So I believe you can understand this chart by yourself. And here break-even quantity is 4,000 and break-even point is this point, and you see cost line and revenue line, they intersect each other at break-even point. And the last problem in this part will be this one, and this one also same problem. You see this is your C and this is your M, this is your small p, and you need to use Q for the number of units. So the revenue, cost and profit function will be this one. Revenue function will be this function because price per unit is 2, and cost function will be this one because this is your M and this is fixed cost. So the profit function you can calculate by this formula, profit equal revenue minus cost, and profit for 1,50,000 units will be what? Profit for 1,50,000 units, if you just put 1,50,000 here instead of Q, then you will get this amount, that will be 20,000. And profit for 80,000 units will be minus $8,000, which indicates a loss of $8,000. And to calculate break-even point, we need to equate profit equal to 0. That gives us Q equal 100,000. So this is our break-even quantity, and break-even dollar volume of sales is equal 2 into 10,000, which is 200,000. And F means probably break-even chart, constant break-even chart, level, cost, revenue, cost, comma, revenue line and fixed cost line, and break-even point. So I think you can try this, try to draw this chart by yourself. Although let me show you quickly. The break-even chart will be what? Just a quick review. Let me give here, this is your axis notation, Y as well as R, and this one will be Q axis, since here Q is the number of units, and cost break-even point is this point, 100 units and 2 lakhs. So let's say 100 units is 100,000 units is here, and 2 lakhs is this point. So it's your choice. You can just put break-even point anywhere, and you need to consider this distance 200,000. Then you can have a look here in the cost function. So cost function initiates from 40,000. So if it is 200,000, then 100,000 will be here and 40,000 will be here. So your cost line will start from here and revenue line will start from here. So now you can easily sketch it. You can easily sketch the cost line, and this is your revenue line, and this is fixed cost line, and this is the break-even point, which is 100,000, comma 200,000. So that's all in this lecture, and in our next lecture we will again discuss this topic, and we will show some other types of examples in our next part. Thank you very much.